Auruin is one of the oldest known coelurosaurian dinosaur to have lived, dating back to 161 million years ago in the late Jurassic period. The specimen, as can be judged from the available skeletal structure, represents a small bipedal predator. The type specimen is a juvenile individual and measures about 1 meter long. The relatively large orbit of Auruin is not indicative of what would be expected of an adult morphology. In their cladistic analysis of Banacus, Su recovered Auruin as a basal Alvarezsaur. This assignment has been questioned. Analysis conducted by Kota Kubo and colleagues with their description of the genus Jaculinicus in 2023 found it to be one of the most basal Alvarezsaurs, being slightly more basal than the contemporary genus Haplochirus. Alvarezsaurus is considered basal to better-known members of its family. It has been alternately classified with both non-avian theropod dinosaurs and early birds, but a move of the Alvarezsaurids to be recognized as more closely related to neornithine birds proved controversial despite being supported by earlier studies. Like other lightweight theropods, it had a long tail, and its leg structure suggests that it was a fast runner. The most proximal elements of Alvarezsaurus caudal vertebrae exhibited ventrally sharp centra, and the transverse processes of these vertebrae were subtriangular and laterodistally directed. Spinal processes were entirely absent or poorly developed, and each caudal vertebra supported short presygapophyses. The scapula was visibly curved and proportionally smaller than those of other Alvarezsaurids, and unlike its relatives Alvarezsaurus did not have a fused astragalus and calcaneum. Linhenicus was a small dinosaur, about 50 centimeters long and weighing 500 grams. It belonged to the Alvarezsaurid group, known for their short forelimbs with a single, enlarged second digit. While most Alvarezsaurids retained reduced third and fourth digits, Linhenicus is unique as the first to have only one functional digit on each forelimb. Its third digit had no finger bones, and the fourth metacarpal was likely absent. Despite having highly reduced digits, it is considered a basal member of its group, as its claw was not as robust as those of more advanced forms. Scientists believe it may have been insectivorous, using its claws to dig into ant or termite nests, similar to modern anteaters. Menonicus was a small dinosaur, measuring about 1 meter long and weighing 3 kilograms. It had several bird-like features, such as fused wrist bones and a keeled breastbone, which are traits shared with its Alvarezsaurid relatives. Unlike close relatives, it had unique skeletal details, including a triangular pubic bone and distinct toe proportions. It likely had a feathered covering, as evidence of feathers has been found in related species, suggesting that Alvarezsaurids were among feathered theropods. Its inner ear structure resembled that of barn owls, hinting that Menonicus may have had a facial disc of feathers to help focus sound, similar to modern owls. As a member of the Alvarezsauridae family, it had highly specialized, stubby forearms with a single large claw measuring about 7.5 centimeters. The other two claws had disappeared, unlike its relative Shibuya, which retained vestigial claws. While the function of its unique arms remains unclear, some scientists believe they were used to break open termite mounds, suggesting an insectivorous diet. Shibuya was a small and lightly built animal. At 1 meter, it is one of the smallest known non-avian dinosaurs. The skull is lightly built with long and slender jaws and minute teeth. It is unique among non-avian theropods in the skull's ability to perform prokinesis, that is, it could flex its upper jaw independently of its brain case. Although originally Shibuya and other Alvarezsaurids were thought to have only a single digit on the front limb, newer specimens show the presence of reduced second and third fingers in addition to the massively enlarged thumb known from previous specimens. It may have used its forelimbs to open insect nests, and its slender, unusually mobile jaws to probe after such prey. However, new research based on analysis of the theropod's ears suggests that it was actually an owl-like, nocturnal hunter which used its strong legs to run down prey, and its arms to dig small prey such as insects and mammals out of burrows and shrubs. Its lagina is about the same size as that of barn owls, giving it superb hearing in addition to its fantastic night vision, analyzed by looking at its scleral ring, allowing it to potentially hunt in complete darkness, unlike other theropods to which it has been compared. Shibuya likely possessed a coat of feathers. It lived approximately 70 million years ago in what is now the Gobi Desert of Mongolia, a region known for its rich dinosaur fossil record. During the late Cretaceous, this area was likely a semi-arid or desert-like environment with sand dunes, sparse vegetation and intermittent water sources. The climate would have been harsh, with temperature extremes and limited resources. In 2011, Alifanov and Savliev described the brain case of Ceratonicus, highlighting unique features in its brain anatomy. Unlike crocodiles, birds, and other dinosaurs, the brain had no bends in the parasagittal plane between the mesencephalon and myelencephalon. The optic and auditory lobes were separate, with the optic lobes displaced ventrolaterally, resembling birds. They also noted that it had a transverse sulcus in its cerebellum, like crocodiles, suggesting better movement coordination than lizards. This led the authors to hypothesize that Alvarezsaurs may have had arboreal ancestors, capable of navigating three-dimensional spaces. Additionally, they proposed that a complex cerebellum helped terrestrial Alvarezsaurs with fast, varied movements like jumping. Enhanced senses of sight, hearing, and smell likely contributed to their hunting efficiency. Later studies supported these findings, noting that Ceratonicus had an enlarged spinal cord and cerebellum, suggesting locomotor improvements in Alvarezsaurs. Albertonicus is the smallest Alvarezsaurid discovered in North America, measuring 1 meter long and weighing 5 kilograms. Like other Alvarezsaurs, it had slender hind legs, a long, rigid tail, and short but powerful arms with a large claw. While no skull has been found, its relatives from Mongolia suggest it likely had a long snout with tiny teeth, similar to anteaters. It likely fed on insects, using its claw to tear open rotten logs to find prey, particularly wood-nesting termites, as mound-building termites and ants were not yet common during the Cretaceous. The fossil record from the Horseshoe Canyon Formation, where Albertonicus was discovered, supports this idea, as petrified wood from the site shows termite-like borings. Classified within the Alvarezsauridae family, Albertonicus is part of the Asian clade Mononychini. Its discovery in North America supports the theory that Alvarezsaurs originated in South America and dispersed to Asia via North America. Echinosaurus is one of those dinosaurs where we're not entirely sure what it should be classified as, because we don't have a lot of material from it, only part of the lower left jaw. If it was a therizinosaur, it would therefore be one of the oldest known, and the oldest known coelurosaur. Given the characteristics of the jaw, it was classified as a therizinosaur, a group of strange theropods that were at least partially herbivorous, with long claws on the hands and bulky bodies, long necks and small, slender heads. But this would make it be a Maniraptoran living long before Archaeopteryx and 60 million years before any other known therizinosaurs. There is a possibility, thus, that it could in fact be a prosauropod, given the similarity of the jaw to the prosauropod Lophangosaurus. However, there are other features in the jaw that are shared with therizinosaurs and not with prosauropods, which would have profound implications for the evolutionary history of coelurosaurs. Falcarius is an interesting find in that it is a basal member of therizinosaurs, known from several fossils. It was a more transitional form of therizinosaur, showing features of both therizinosaurs and older theropods. Its teeth, in fact, were both pointed and leaf-shaped, indicating that it was omnivorous, unlike later therizinosaur forms. Its claws were not that much longer than of regular theropod forms, indicating that the huge claws characteristic of therizinosaurs were not yet developed. It, like later therizinosaurs, had a long neck, small head with adapted teeth, and robust arms. However, like other theropods, it had a long tail and longer legs. Thus, it is in the least derived therizinosaur group. It, along with other early therizinosaurs, give us a clear picture of the evolution of this group. While the smallest specimen was approximately less than 1 meter, average adults were about 5 meters in length. Gigantosaurus was an early therizinosaur, a group of theropod dinosaurs notable for evolving herbivory, a trait unusual for theropods. It was about 2 meters long and 1 meter tall, lightly built, and adapted for speed and agility, unlike its slower, pot-bellied later relatives. Its most unique feature was its long, straight jaw with numerous teeth similar to herbivorous dinosaurs like ornithopods and ceratopsians, indicating its adaptation for chewing tough vegetation. This jaw also supported a beak and had a downturned lower section, suggesting it was well suited for plucking leaves. The jaw was robust, allowing for a strong bite force, giving Gigantosaurus a wide range of dietary options. Feather impressions suggest it had wide, unbranched feathers likely used for display, although only the feather ends have been found. Living in an ecosystem with predators like Uranus, it was likely a fast, skittish animal. Bipiosaurus was a unique therizinosaur, distinguishable by several derived traits, including a large skull, fused tail vertebrae forming a pygostyle, and a triangular flange on its first metacarpal. Its skull was notable for several cranial features, such as a large postorbital joint and distinct mandibular fenestra. Feather impressions on Bipiosaurus revealed both short downy feathers and unique, longer filamentous feathers, which were simple, unbranched, and broader than those of other early feathered dinosaurs like Sinosauropteryx. These longer feathers, up to 15 centimeters, were likely stiff and hollow, possibly used for display rather than flight. The presence of both fine and larger feathers suggests a combination of insulation and ornamental use, potentially for social interactions. Color analysis of melanosomes in the feathers suggests it had a dark brownish coloration, similar to modern reptiles. The unique and bizarre features of therizinosaurs have encouraged research into the paleobiology and paleoecology of the family. A fair portion of modern research has concentrated on the feeding patterns of these dinosaurs, as they are considered to be the best-regarded theropod candidates for herbivory. While other theropod groups are fully carnivorous, members of Therizinosauridae diverged and adopted an herbivorous and possibly omnivorous lifestyle. This is even more supported by their unusual morphology. As indicated by their feet morphology and several footprints from Asia, Africa and Europe, they probably were plantigrade walkers, but further examination may be required. In a 2006, Sarah Birch presented the inferred range of motion in the arms of Nimongosaurus and concluded the overall motion at the glenoid humeral joint at the shoulder was roughly circular, and directed sideways and slightly downwards, which diverged from the more oval, backwards and downwards directed ranges of other theropods. This ability to extend their arms considerably forwards may have helped Nimongosaurus reach and grasp for foliage. Therizinosaurus was one of the last and the largest representative of its unique group. It could grow up to 10 meters long and 5 meters tall, and weigh possibly over 5 tons. It would have been a slow-moving, long-necked, high browser equipped with a horny beak and a wide torso for food processing. Its forelimbs were particularly robust and had 3 fingers that bore unguals which, unlike other relatives, were very stiffened, elongated and only had significant curvatures at the tips. Therizinosaurus had the longest known manual unguals of any land animal, reaching above 50 centimeters in length. When Therizinosaurus was first described in 1954, its enormous claws were thought to be used for harvesting seaweed, based on a mistaken identification as a giant marine turtle. By 1970, some proposed the claws might be for opening termite mounds or for a fruit-based diet. Barsbold in 1976 suggested the claws could impale or dig, but noted their fragility. Nesev in 1995 proposed they were for defense and that juveniles might have used them for climbing, similar to modern sloths. In 2014, Lautenschlager's digital simulations indicated that while the claws were highly stressed in scratching or digging scenarios, they were less effective for these purposes. The claws were likely used for a hook-and-pull function to grasp or pull vegetation. Lautenschlager also noted that the claws might have been used for intimidation or other behaviors, but not for active defense. Scott A. Lee and Zachary Richards in 2018 found that Therizinosaurus had resilient arm bones, suggesting robust use of the arms. However, a 2023 study by Cheen and colleagues found that the claws might have been decorative rather than functional, resulting from evolutionary growth rather than practical use. Segnosaurus was a large therizinosaur estimated to be around 7 meters long and weighing about 1.3 tons. This bipedal dinosaur had an upward-tilted trunk, a small head with a beaked jaw, and a long, slender neck. Its lower jaw was downturned at the front, and its teeth featured additional cutting edges and denticles. It had robust forelimbs with 3 large clawed fingers and feet with 4 toes, a distinctive feature compared to other theropods that typically had 3 toes. The pelvis was adapted to support its large belly, with a backward-turned pubic bone seen in birds and their closest dinosaur relatives. Discoveries in the 1990 of complete relatives confirmed that Segnosaurus belonged to the Therizinosauridae family. These therizinosaurs were slow-moving herbivores, using their long limbs, necks and beaks to browse for food and processing it with their large guts. Segnosaurus lived in the Bayan Shire Formation alongside other therizinosaurs like Erlikosaurus and Enigmasaurus, suggesting a niche partitioning among these related species. Erlikosaurus is known from fragmentary remains, which makes its exact size difficult to determine. Estimates place it at around 3 meters in length, making it smaller and more lightly built compared to the heavier Segnosaurus. Despite the limited postcranial remains, it is believed to have had robust arms with large claws, a broad torso and a backward-turned pelvis. Based on feather impressions in related therizinosaurs like Bipiosaurus and Gianchingosaurus, it is likely that Erlikosaurus was feathered. CT scans of the skull revealed well-developed senses of smell, hearing, and balance, traits commonly found in carnivorous theropods. Analysis of the olfactory bulb suggested that it had a moderate sense of smell, potentially reflecting a transition to complex social behavior or reduced visual capacities. Nothronicus is a medium-sized therizinosaur, measuring 5 meters in length and weighing 1,000 kilograms. It had a pot-bellied abdomen, long neck and stocky hind limbs with 4-toed feet. Its arms were large with dexterous hands equipped with up to 30 centimeters long, curved, and sharp claws. The tail was reduced in length but flexible. It can be identified by unique skeletal features such as a subcircular obturator process and an elongated obturator foramen. It is believed to have been herbivorous, supported by its dentition and large gut capacity. The 4-toed feet and robust limbs suggest a slow-moving lifestyle. Biomechanical studies indicate that its claws were more effective for pulling down vegetation rather than digging. The genus is also noted for its adaptation of a retroverted pubis, indicating herbivory and possible evolutionary convergence with Ornithischians. Myological studies reveal that the neck had limited movement, similar to ostriches and Diplodocus. The forelimb musculature showed similarities to dromaeosaurs, while the hindlimb musculature suggests a waddling gait. Research on the sensory capabilities of Nothronicus shows well-developed senses of smell, hearing, and balance, suggesting complex behavior and predator evasion. Its brain case had large pneumatic chambers, implying enhanced hearing and possibly complex social interactions. Additionally, the extensive pneumaticity of its axial skeleton indicates an avian-style respiratory system, although it might not have had a complete avian air sac system.